Okay, so let's talk about this problem where we've got these three balls here, each of which has the same mass, mass of m each. They're separated by d1 and d2, and we want to find the force on ball B. So find the force there. Okay, so there are going to be two forces acting on ball B. One of them is going to be from ball A, and one's going to be from ball C. So let's look at ball A first. First thing we want to ask ourselves is, which way is this going to go? And I think it's pretty obvious that since gravity always attracts, this is going to go up. So that's the force of ball A on ball B. So let's go ahead and figure out what this is. Let's figure the magnitude first. Okay, so we just use our standard gravitational force equation. G, let me do m1, m2, but these both have a mass of m. So that really just turns into m squared. And then the distance here between the two of them is d1 squared. So that's the magnitude. If we want to make it a vector, we have to take this magnitude and put some kind of direction vector on it. So which direction is this heading? Well, it's heading along the positive y-axis. So that is the positive y direction. So it's the j hat unit vector. Pretty easy. All right. So let's label that. That's the force of A on B. And I can also label that. Okay, let's look at the force of C on B, and the magnitude of that is going to be capital G times m squared over d2 squared. And the direction of the force, well, which way is it going to go? It's going to go towards C, because it's attractive again. So we just do FCB equals capital G times m squared over d2 squared. And that is going in the positive x direction, so that's going to be I hat, the unit vector there. So now let's take these two and add them together. So we could call this, like, I don't know, let's call it F. Is going to be the sum of these two forces, FAB plus FCB. And then it's going to equal capital G. So let's see, these two go together, so we can collect the g m squared terms, right? So this is going to be 1 over d1 squared j hat plus 1 over d2 squared I hat. Okay, so this should be pretty simple at this point. So what I want to do here, we want to find the magnitude of these things. Let's see. Do we want to? You know what? I think I'm just going to go ahead and get numbers and then do it that way. I don't want to take this symbolically any further. So let's take the numbers from the sample I got. So 3 kilograms is the mass, 0.2 meters for D1 and 0.3 meters for D2. So mass is 3 kilograms, D1 is 0.2 meters, D2 is 0.3 meters. And so let's see what that gets us. So G is going to be 6.67, whoops, 10 to the minus 11. M is going to be 3, and then D, I'm going to have to call these dA, because if I try to do D1, it's going to get confused. dA is 0.2, and dB is 0.3. So let's look at, let's see, 6.67 times, or sorry, capital G times m squared times, let's see, 1 over d1 or dA squared, and that's going to be our j hat. Actually, let's do dB first so we can do our I hat component. So that is going to be, oh my god, that's tiny. Let's see, which is what you'd expect, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So, my god, is that really it? I guess so. 6.6. Oh yeah, right. Okay. So our force then is going to be 6.6. Oops, sorry. 6.67 times 10 to the minus 9th I hat newtons. 1, 2, 3, 4, 5, 6, 7. Yep. And then let's try it over dA and see what the j component is. And that is going to be plus, you know, I don't know, 1.5 times 10 to the negative 8 j hat. Okay, plus 1.51, I believe, or 1.507 times 10 to the negative 8 j hat. And boom, boom, and then we draw brackets around all these and do newtons. And right, so what we want is the magnitude in newtons. So let's take those and let's do the square root of, and you know what, let's just, wonder if I can copy and paste here. Let's see. Boing. Excellent. Okay. So, but now I have to like square all that and take all this and square that, and oh no, wait, square everything. Yeah, okay, got it. And then this should close it out, and that should give us, holy crap, okay, so 1.64 e minus 8 should be our magnitude. Let me make sure I got that right. E minus 8. Chug, chug, chug. Yes. Okay, so then what is our direction? And that's just going to be the arctan. So let's see, this is going in the positive, so this is going to be in quadrant 1, so it's going to be arctan of the y over the x. So the arctan of about 1.507 divided by 0.0667. So it's atan 1.507 slash 0.667. It's going to be 66 degrees. Let's see if that's what we want. 66 point, oh, let's just be 66.1 degrees. And there you go. There's problem 1.